Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for October, November 2024, paper 3-1, part 1 for questions 1 to 5. Question 1, the polynomial 4x cubed plus ax squared plus 5x plus b, where a and b are constants, is denoted by p of x. It is given that 2x plus 1 is a factor of p of x. When p of x is divided by x minus 4, the remainder is equal to 3 times the remainder when p of x is divided by x minus 2. Find the values of a and b. Now here we are going to use the factor remainder theorem. Okay, in my chapter summaries here, that is chapter, yes, the first one here. So we have, this is the division algorithm for polynomials. P of x is equal to the divisor, then times the quotient plus the remainder. So now if we get the value of x for the divisor and we put it here, okay, that means this whole thing is going to go. That means the p of that x is going to be equal to the remainder. Okay, it's going to be equal to that remainder. This is what they are saying here, the factor theorem. If a polynomial p of x, then we have p of c is equal to 0, then x minus c. Remember, the divisor is going to be x minus c. Okay, so when you equate this one to 0, your x is equal to c. So it is the one we put in the polynomial and then it gives us a 0. You see? And what we get is the remainder. So if a polynomial p of x, we have it here and then we put p of b over a and we get 0, that means this ax minus b is equal to, is the factor. You see? And also this other one here, the remainder. If we have the polynomial p of x and it is divided by x minus c, the remainder is p of c. Okay? And this other one here for ax minus b, then p over b. Now, we come back to this. When we equate this one to 0, the 2x plus 1, and you equate it to 0, that means your x is going to be negative a half. So meaning we shall get p of negative a half. Since it is a factor of p of x, it should give us the remainder, which has to be a 0. Okay, so we substitute and we say this is going to be 4 into negative a half cubed, then plus a into negative a half squared, then plus 5 of negative a half, then plus b, and then we equate to 0. So putting this in the calculator, all the power of a negative is always a negative. So we have 4 over 8. That one will be negative a half here. And then this one will be a over 4. Then minus 5 over 2 plus b, which is going to be equal to 0. Then I can multiply all through by 4, which is the LCM of 4 and 2. So here I'll get negative 2, and then here I get a, here I will get negative 10, then here I will get 4b, which is equal to 0. Rearranging this, I can have my a plus 4b, which is equal to 12. That is my first equation. Then the next one, they said when p of x is divided by x minus 4, the remainder is equal to 3 times the remainder when p of x is divided by x minus 2. So what I'm going to do, this one actually means that we have p of 4 is equal to 3 times, okay, p of 2. So now I substitute. I put 4, okay, 4 cubed here, then plus a into 4 squared, then plus 5, then times 4, then plus b. This one is going to be equal to 3 times. 3 times, then now put 2. We shall have 4, then 2 cubed, then plus our a, then 2 squared, and then plus 5 times 2, then plus b. Okay, and then this is 4 power 4. We shall get 256. Then this will be 16a plus 20, then plus b, which is going to be equal to 3 times. What is inside here is 8 times 4, that is 32. Then we have 4a we have 10, and we have b. Then when we open those brackets, because here we shall have 276, then plus 16a plus b, then is equal to 32. This is 10 plus 32, that is 42. So times 3, we shall get 126. And then 4a times 3, that is 12a, and then plus 3b. So I can rearrange this, bring the 12 this other side. So 16 minus 12, you will get 4 of a. And then b minus 3b, you'll get minus 2b, which is going to be equal to 126 minus 276. That one will give us negative 150. And I can divide all through by 2. Then I can get 2a minus b, which is equal to negative 75. So this is the second equation. And then I can solve these two simultaneously. Okay, so I can have my a here, and then 4b, okay, which is equal to 12, and then 2a minus b, which is equal to negative 75. So if I use elimination, maybe I can multiply this by 2 and then this by 1 to eliminate a. So I'll have now 2a plus 8b, which is equal to 24. And then here we shall have 2a minus b, which is equal to negative 75. When I subtract them, since the coefficients are the same, are of the same size, you just subtract. So we shall have now 8 minus b, 8b minus b, that will be 9b. So we shall have here 9b, which is equivalent to 24 minus 75. So they add up, we shall get 99. So if we divide all through by 9, that means our b is going to be equal to 11. And then using any of these equations we have gotten, we can now get the value of a. So using the first one, okay, using that first one, a is going to be equal to 12 minus 4b, which b is 11. So you have 12 minus 44, and therefore our a becomes negative 32. Number 2, find the exact value of the integral from 1 to 3 of x squared natural log of 3x with respect to x. Give your answer in the form a natural log of b plus c, where a and c are rational and b is an integer. An integer is a positive or negative whole number, and then a rational number is the one that can be expressed as a fraction. Now, since we are having the product of two functions, then we are going to use integration by parts, where one function is differentiated and then the other one is integrated. So how do you know that this is the one I'm supposed to differentiate? This is the one I'm supposed to integrate. So we are going to use this acronym. The acronym is called ILET. ILET. So the one which comes before the other is the one we differentiate. So this one here, the I represents inverse, trigonometric functions. Then this one here represents logarithmic functions. A here represents algebraic functions. T here represents trigonometric functions. Even inverse trigonometric functions are trigonometric functions, but those ones are dealt with differently. So that's why we have that I there. E is exponential functions. Now, based on what we are having here, this x squared is algebraic, and then the natural log here is logarithmic. So L comes before A. So the logarithmic is the one that I'm going to differentiate. Okay, so I'm going to let now my U So let my u be the natural log of 3 of x. Then when I differentiate this one, you just get the function here. Remember, when we differentiate natural log of a function, okay, you get the function, you differentiate it, then you divide by that function. Okay, so we shall get 3, then we divide by that 3x. So this one can disappear, and then you have 1 over x. Okay, then we can also have our now dv dx is going to be equal to x squared. It's the one we integrate. Okay, so we have the integral of this one automatically is going to be x cubed over 3. Now, in the list of formulae, you are even given the this integration here. So this is differentiation, and then the integration is here. It is here. You integrate u dv dx, which is equal to now uv minus the integral of v du dx. Okay, so that is what we are going to use here. So we are using integration by parts. So using integration by parts, the integral of u dv dx with respect to x will give us uv minus the integral of v du dx with respect to x. So therefore, what we are having here, the integral from 1 to 3 of x squared, natural log of 3 of x with respect to x. This one is going to be, our u is natural log of 3x, then times v, which is x cubed over 3, minus the integral of v, which is x cubed over 3, then times du dx is 1 over x, then with respect to x. I can actually put the limits right away here. Now, it is better you write this function here first, so that you don't confuse it with the 3x, which is in the natural log. So I can write x cubed over 3, then natural log of 3 of x, then minus. Now here we shall integrate. Of course, this one reduces this to x squared. So I can put the third here. Okay. Then we shall get x cubed over 3, the natural log of 3 of x, then minus a third. Again, this one, when we integrate, it will be x cubed over 3. So we put now the limits. So when we put the limits, we shall put 3 cubed is 27, divided by 3, we get 9. Then natural log of 9. Okay. Then after that, we shall subtract. Put 3 here. 3 cubed is 27. Then divide by 9. You will get 3. Okay. Then we now subtract when we go to the lower limit. So that is 1 over 3. Then natural log of 3. And then minus 1 over 9. Now, since I've seen natural log of 3 here, and then 9 here, and yet 9 is the square of 3, I can represent it, I can express it in terms of the natural log of 3. So I can write 3 squared, then minus this 3, now minus a third, natural log of 3, then plus, because the negative affects this one, 1 over 9. Now, this one, using the rules of logarithms, it will come this side and it multiplies with that 9. So we shall have 18 natural log of 3. Now we shall subtract a third, natural log of 3. Then you have minus 3 plus 1 over 9. Okay. And then after that, we can simplify this. So 18, you can see here that natural log of 3 is common. So 18 minus a third what do you get? Then natural log of 3 minus this other one here. In fact, I can put plus. The LCM is 9. So 9 divided by 9, you get 9, then times 3. That will be 27. So negative 27, then plus 1. 3 times 18, 54, minus 1, you get 53 over 3. Natural log of 3. And then 1 minus 27, of course, that is negative 26 out of 9. So this has to be our answer. And remember, they said that A and C are rational numbers. So A here, you can see it's a rational number, and also this one. And then B is an integer. Question 3, the equation of a curve is natural log of x plus y, which is equal to 3x squared y. Find the gradient of the curve at the point 1, 0. We use differentiation to find the gradient of a curve. Okay, so we need to differentiate both sides, and then we make dy dx the subject of the formula. That will be the gradient when we substitute these coordinates for x and y. So we shall have to differentiate the left side, the whole of this with respect to x. Then we also go this side, but this is a product of two functions. So we use product rule. We shall keep this one constant. Then we differentiate y. Then now plus y. Then differentiate. In fact, I can say 3y. Then I differentiate x squared. Okay. Now, we also know that when you differentiate a function, a natural log of a function, okay, you get that function, you differentiate it, then you divide by that function. Okay, that is one thing. Another thing is when we are differentiating, now this one is what we call implicit differentiation. Y is not expressed in terms of x. Okay, so it is an implicit expression. So what we need to do when we are differentiating with respect to a function of y, okay, we are with respect to x, we are differentiating a function of y with respect to x. That means we are going to first differentiate, okay, we are going to first differentiate that function of y with respect to y. Then after we multiply by dy dx, such that this dy can cancel with this dy, and you remain with your d dx of f of y. You see that? So we come to this. Inside here, we are going to differentiate x. It will give us a 1. When we differentiate y with respect to x, it will give us 1, then times dy dx. So we shall just put here dy dx, and then we divide by the function inside the natural log is x plus y, then which is equal to this other side, we have 3x squared. When you differentiate y with respect to x, you are going to get first differentiate y with respect to y, which is 1. Then now times dy dx. You see? And then plus 3y, then times 2x. Okay? So remember, I'm given these coordinates, x being equal to 1 and then y is 0. So I just substitute accordingly. So 1 plus dy dx out of 1 plus 0, which is equal to then 3 times 1 squared, then dy dx, then plus 3 times 2, that is 6. Then y is 0, of course x is 1. Now we make dy dx the subject of the formula. You don't need to simplify this to find the dy dx. They just need the value of that dy dx. So here we can make it now the subject. We have y plus dy dx is equal to 3 dy dx. So I can take this one this side, and I say 1 is equal to 3 dy dx minus dy dx. automatically you're going to get 2. Okay, so we shall get a 2 here of dy dx. Therefore, your dy dx is now going to be 1 over 2. So the gradient of this curve at that point is a half. Next, number 4, part A, show that sec power 4 of theta minus tan power 4 of theta is the same as 1 plus 2 tan squared theta. There are 2 ways I'm going to solve this. Okay, number 1, I can use a difference of 2 squares. Okay, using a difference of 2 squares. This is one of the identities that you must know in mathematics. If I have a squared minus b squared, this one is equal to a plus b, then a minus b. You see? Now, sec power 4 theta minus tan power 4 theta, it is actually the same as saying sec squared theta squared, then minus tan squared theta squared. Now our A is sec squared theta and our B is tan squared theta. So that means I can have sec squared theta plus tan squared theta, then sec squared theta minus tan squared theta. Then I simplify this. From the Pythagorean identity, we can prove this. From trigonometry, you can just come and check here. We have 1 plus tan squared, this one here. 1 plus tan squared theta is equal to sec squared theta. So I go back where there is sec squared theta and I put 1 plus tan squared theta. So there is also this other tan squared theta. Okay, and then inside here still I'll have 1 plus tan squared theta minus tan squared theta. So we can see that actually here we are having 1 plus 2 tan squared theta, but inside here tan is disappearing, so we are now multiplying all through by 1. So this is the answer proved. Alternatively, you can also do this. You can say our sec power 4 theta minus tan power 4 theta again is the same as saying sec squared theta, okay, minus tan squared theta. Then sec squared is 1 plus tan squared theta. Then we square minus this one. Let me just leave it as that. Now you expand this, it will be 1, then plus 2 times 1 times tan squared, that is 2 tan squared theta. Then square the tan squared, you get tan power 4 theta, then minus tan power 4 theta. So you can see that this one cancels and you get your answer 1 plus 2 tan squared theta. Part B, hence or otherwise solve the equation sec power 4 2 alpha minus tan power 4 2 alpha, which is equal to 2 tan squared 2 alpha sec squared 2 alpha for alpha ranging from 0 to 180 degrees. Already we have seen this one here, okay, as 1 plus 2 tan squared theta. But now the theta is now 2 alpha. So that means we are going to have 1 plus 2 tan squared. Instead of theta, I'm going to put 2 alpha. Okay, they have said hence, so I'm using the hence, not the otherwise. Otherwise, you can start from whichever you want, but hence means begin from where you have stopped. Find a way of applying what you have gotten into this other one. So we have 2, then tan squared 2 alpha, sec squared 2 alpha. So we shall have 1 plus 2 tan squared 2 alpha, which is going to be equal to, we have here, sec is the same as 1 plus tan squared, okay? This will be now 2 alpha. So when I open those brackets, I will now have 2, then this one times 1, so it will be 2 tan squared 2 alpha, then plus now 2 tan power 4 2 alpha. Now this one is on both sides, so it can go. Then we can have this 2 tan power 4 2 alpha, which is equal to 1. Then I can divide all through by 2. I get a half. And then I can now take the fourth root. So tan of 2 alpha is going to be now the fourth root. And this is an even power, so we have to put plus or minus 1 over 2. Okay? The fourth root. Let me put the 4 here. Okay. Then we split this into 2. Our tan 2 alpha is going to be equal to the positive 1, the fourth root of a half. And also tan 2 alpha is going to be the negative 1, the fourth root of 1 over 2. Now, that means that our 2 alpha is going to be the arctan of the fourth root of 1 over 2. So since the domain was given in degrees, okay, since the domain was given in degrees, that means your calculator should be in the degree mode, okay? All right, now we can get our calculator. Actually, our x here, I mean, the alpha is going to be a half of the arctan of this. So what I can do here is to first find the 2 angles where this tan is positive, okay? I always use the 4 quadrants, and all of them are positive in the first quadrant. Here it's only sine, only tan, only cos, 0. This is 90 degrees, 180 degrees, then this one is 270, and then when you come back here to 360. So if I have an angle here, that'll be the theta. When I project it this other side, this is theta. That means when you move from here to here, that one will be 180 plus the theta. And then also if I project this theta here, so that means to move from here up to here, it will be 360 minus the theta, which is here, okay? So we look at the deviation of these angles on the horizontal, the 180 and the 360. And also here, from here up to here, it will be 180 minus. But if you want, you can sketch the graph, okay? Now, tan is positive here and here. But since our domain is from 0 to 180, that means we shall take only the one in the first quadrant. But remember, there is a division here. We are supposed to divide by 2. So what you can do is to first get those 2 angles. Whether it is bigger than 180, first get those 2 angles, because at the end of it all, you are going to divide by 2. Okay? So I'm going to get the calculator, and I put the arctan of the fourth root, okay, of the fourth root of a half. So this is 0.5. I'll put power, that is 0.25, okay, and we get 40.06 and the rest of those figures. But since I'm going to divide by 2, I can write my answer to 2 decimal places, okay? So I'll write here 40.06. To be so accurate, you can write these ones to 2 decimal places or 3, and then you round off to 1 decimal place at the end, okay? So the next one where tan is positive is here. You see, 180, then plus. So we shall have 180, then plus the 40.06, okay? Then here, the 2 alpha is also going to be equal to the arctan of the negative fourth root of 1 over 2. Now here, when you put the negative of this one here, the calculator is actually going to give you the negative of this answer. Okay? So if I just put the negative of this one, the calculator will just give me the negative of that. So what I can do is to ignore the negative. I still remain with my 40.06. Then I go to the quadrant, to the quadrants where tan is negative. So tan is negative here and here. So in the second quadrant and fourth quadrant. So in the second quadrant, we say 180, then minus that 40.06. And then in the fourth quadrant, it is 360 minus that 40.06. So when we come back to this, then we can divide all through by 2. So we can have 20.03. And then this other one here is going to give us 110.03. Then when you come to this one here, you will get 69.97. And then the other one is going to be 159.97. Okay. Let me check again here. You have 0.5 times 0.8. I mean, 180 when you subtract 40.06. So you see, 69.97. And then the other one is 360 minus the 40.06, then a half of that. That is 159 point that. Now, to one decimal place, we are going to have our answer as alpha is equivalent to 20.0. Then we have 69. It will now be 70.0 to one decimal place, this one here. And then I'm writing them in ascending order. Then this one here is 110.0. And then this other one here will give us 160.0. All of them to one decimal place. Okay. Now, do you see that getting these two angles is very important at first before you do any other manipulation? You see? So if you had gotten only one value, because you know tan is positive in the first quadrant, so in the second quadrant it will be beyond 180. These values here are for the two alpha, not alpha. Alpha is the one which is ranging from 0 to 180. So you first get a pair, then you can do the other computations. Question 5, part A. By sketching a suitable pair of graphs, show that the equation 2 plus e to the power of negative 0.2 of x is equal to natural log of 1 plus x has only one root. That means we are going to sketch the two curves. Maybe one is coming like this and then another one like that, and then they meet at one point. Okay, so if we show that, then that means that there is only one root, and where they meet, that is the solution. So it is that root. Now what I can do is to put a table. Okay, I can put a table here for the two graphs. Maybe one is going to be for, this can be for x here, then I have y here. So we can have x here, then maybe y1, I let it be the one on the left, 2 plus e to the power of negative 0.2 of x, 2 of x, and then y2 is going to be the natural log of 1 plus x. Then I can choose values. Of course, we cannot have natural log of a negative, so I'm going to use only the positives. Okay, so for example, if I can take 0, then maybe 2, 4, 6. You need like 4 or 3 coordinates. Okay, 8, but let me take it up to like 10. And then which values do we get here when we substitute in these functions? Then I put in the calculator. So this is the easier way to use the calculator in that sense. We are going to put, you go to your calculator. First, it is like this. Then I want to put a function y1. So I will put here, I will come to my mode. Then I put 7. Okay, 7, the table. And then f of x is equal to what? So I write 2, then plus. We have shift, then this natural log, then the e comes with the power negative 0.2, then alpha, alpha this one here, then it gives me the x. Then I press equals. So start with what? I'm starting from 0, okay? And then end with 10. So I'll put 10 there. Then step, what are you adding on every now and then? So I'm adding 2, so I can say maybe 2. Now I can write the values. When x is equal to 0, we are seeing 3, okay? So there is 3, 2.67. This will be 3. I write 3 here, then 2.67. Then the next one is going to be 2.45. We check again. Now we can go down 2.45. Then when it is 6, 2.30. Okay, 2.20 and 2.13. Okay, 2.30, 2.30. Then we have 2.20. Then I also have 2.14. And then this other one, I can now put another function. Okay. I come to this. So it is asking for the function. I just put natural log of 1 plus alpha x. Okay. So that not every time you are going to be putting the value of x. No. You just put it all at once. We are starting from 0. We are going to 10. The step is 2. So these are the values. The first one is a 0, because when you put a 0, you are going now to get natural log of 1, which is a 0. Okay, so we have 0 here. Then the next one is 1.10. Okay, let's check. 1.10, then 1.61, 1.61. Then if we go down, then we have 1.95, 2.20, 1.95, 2.20, and 2.24, 2.24. You can see actually at 8, they have the same value. So don't you think that is the root? I think that is the root. Now, we are going to now plot. So I can plot, put my axes here. So I have this, then the other one there. Okay, then I will have, this is x, then this is y. We have the 2, we have the 4, the 6, the 8, the 10. Then we have 1 here, 2, 3, we have 4. So the first one here crosses y-axis at this one here. And then 2, we have 2.67, so beyond here, beyond the mid. Then 2.45, approximately in the middle. Like, let me put this one here, then this one just down there. So it goes on like that. So I can just sketch something like that. Okay, that curve is going to be a diminishing one. Okay, just like that. Then for the natural log, for it is going to go like that. And we can see 0 with 3. So we have 0 here, 0 with 0, so it is passing through that. Then 1.10 just here, 1.61 there, then 2.3, I mean 1.95 there, then 2.2. Okay, so they are meeting maybe there. That's where 2.2 is, and then 2.24 is just above. So for each, it is coming like this. Okay, this is the one for y is equal to natural log of 1 plus x. And then this one is for y, which is equal to 2. plus e to the power of negative 0.2 of x. So they meet at one point. So that is how we can show it graphically. And then show by calculation that this root lies between 7 and 9. 7 and 9, actually we have seen it is around 8 here. We have seen that on 8, okay, on 8, they all have the same values here, the 2.20 y value. You see that? So it is in between 7 and 9. Now let's, of course, it has to be the x value. So the x value has to be like that, 8, around there. So let us just substitute here because the other one is just, they are rounded off. So what you can do, you bring everything onto one side, okay? We have the equation 2 plus e to the power of negative 0.2 of x, which is equal to the natural log of 1 plus x. You can choose to bring all the functions onto one side. So I will have this, then minus the natural log of 1 plus x, which is equal to 0. That means my function in terms of x is 2 plus e to the power of negative 0.2 of x, then minus natural log of 1 plus x, which is equal to 0. Then I substitute. When I put 7, what do I get? When I put 9, what do I get? So we are going to put 2 here plus e to the power of negative 0.2 times 7, then minus the natural log of 1 plus 7. Okay? Actually, let me remove this one is equal to 0. A root is that function that you're going to put in the function and it reduces it to 0. Okay? Then 9, when you put 2 e to the power of negative 0.2, then times 9 minus the natural log of 1 plus 9. So what do we get? Now we can get our calculator here and then we put in everything. So I'm going to put this whole thing 2, then plus e. I think let me just go back to the normal one. 2 plus then e to the power of negative 0.2 times 7, then minus natural log of 1 plus 7. So this one gives us 0.1671, 0.1671, 0.1671, and the rest of the other figures, 5, 5, 4, whatever. And then these others, let us now go and change the 7 to a 9, okay, to a 9. And now we are having a negative 0.1, negative 0.13, 728, 72862, okay, 0, and the rest. So there is change of sign. Now you conclude. So if I'm plotting a graph, let's say this graph was coming like this, and then it was crossing the x-axis, okay? So this is the root where it is cutting the x-axis, so the y is 0. So when I look at the left, the value is a negative. The value on the curve is a negative. When I look onto the right, the value it gives is a positive. So that means on the two sides, even the function can come like this. You look at a value on the right, it gives a negative value for the function. And then the value on the left is going to give the value that is a positive one. So this will be a positive one here. You see that? Now, that therefore implies that on the left and right of the root, there is always change of sign of the function. So I'm going to say, since you conclude, since there is change of sign, since there is change of sign between f of 7 and f of 9, the root lies between 7 and 9. You conclude. So that is that. Part C, use the iterative formula xn plus 1 is equal to the exponent of 2 plus e then to the power of negative 0.2xn minus 1. To determine the root, correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Exponent of x means an alternative notation for e to the power of x. Now, since it is in between two values, 7 and 9, I can let the initial approximation. Let the initial approximation, approximation be the average, So let's say it is x1, it is going to be, since it is in between 7 and 9, you can say 7 plus 9 divided by 2, and you get 8, Then you begin from there. Now x2 is going to be e to the power of 2 plus then e to the power of 0.2, then times, this is 8 here, and then minus 1. So what do we get? Now you get your calculator. We are going to put e, to the power of 2 plus, then again another e here to the power of negative 0.2, then times 8. Then now we come down here and then we say minus 1. So this one will give us 8.04. So they said we give the result of each iteration to 4 decimal places. So this one is going to be 8.0421. 8.0421. Then what is x3? You don't need again to show, but I can just show this one here. 2 plus e. Now this value that I've gotten here, I will say negative 0.2 into the 8.0421, then minus 1. What do you get? So you don't need to show all of this every now and then, You don't need to do that. You just do for the first one. So now we just come back here where there is the 8. Now you put 0.0421. Don't put answer, You put the one of 4 decimal places that you have gotten, So this one will give us 8.02, 8.0269. Then next, x4, when we go back, so we just put here 8.0269, 0269. So we shall get 8.0324. 8.0324. Then what is x5? So you put this one back here. So 8.0324. We get 8.0304. 8.0304. Now, if you can check these three, this one can go to 8.03 to 2 decimal places. Even these ones can go to 8.03, So when you get these 3 results, which are giving the same value, you stop there. You don't continue with the iteration. So we can therefore say, now the root. So therefore the root, I conclude and say, therefore the root is 8.03, to 2 decimal places. Thank you so much. This has been it for this first part of this paper. See you in the next videos. Please, if you like the content that has been shared here, like, share, and even subscribe. See you in the next videos.